time to get rolling. How you guys doing today? Okay.
I live, so I said I'm doing pretty good.
Actually, I'll be right back. Oh, why is your screen so frozen? So I got the recording started. Go ahead and please write down your homework. Get a page out for notes. I'll be right back because I don't have enough water for our lesson.
Water for our lesson. Oh, coffee there? There's coffee in the book. My public decree of the mighty twin, I finally said coffee. Well, I want the coffee. But I want the coffee. But I want it. 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 Yeah.
All right. So we quickly are transitioning from square roots to cube roots. Now, what is a cube root? Aside from, there's funny pictures online of like trees that are grown in boxes and people call them cube roots. I mean, they are, like, physically it grows as a cube.
Watermelon cubes.
Yeah, and they grow watermelons as cubes. So, Quinn, what's a cube root?
It's like square root, but instead it's in a third dimension.
Well, okay, but that if I don't know square roots, that doesn't help me. So, keep talking.
A cube
Or
root
somebody else.
is basically when you take a cube and then you root it. Wait, no.
Yes, that makes sense.
Savannah.
It's the number that you keep multiplying to create a cube.
Okay. Yeah, we'll let that go, but that doesn't really help me understand what it is.
Like square root, but with the third dimension.
But if I don't know what square root is, how does that help me?
Okay.
So what's a square root?
Like the length of each side to get the area of something.
The area of something?
Square.
So if we have a square, two-dimensional, right? Micah is saying that the square root is the edge length that then results in the area of the square. So then, if we try to extend that idea to cube root, how would we talk about a cube root then? Yeah, that's the math. But how do we understand what it is?
Well, it's kind of like multiplying it by the same number, but instead you're not multiplying it. So in the reverse order of squaring something is the reverse of squaring something is multiplying something by the same number. Same thing 3 times.
It's
You
Don't let it go.
overflow.
How do you have so much
Fail.
water?
Fail.
This is a big water bottle.
Can I drink that?
Ew.
Quinn.
Oh, this is making
What?
It's just normal water that's been put into it. What's wrong with that? Not a dirty cube.
Multiple times.
I don't see anything that's dirty about that.
Oil won't fall
Shift the table. Shift the table.
Now wait. I have a question.
No.
Okay, so let's. Oh, we'll leave that there. Let's see if I can trip over that table before I use that water. So, in your notes, please. Cube root. Oh, yeah, my smart board's mad at me today. I can only write on my smart software. A cube root, we're saying, is the edge length. So, write down in your notes, please. Cube root. Well, be careful. Is the edge. Be careful not to really say side, because side is kind of a vague word now. Edge length. Base is also kind of dangerous because base could be a two-dimensional shape. Edge length of cube with a given volume. So you guys have been learning about this in science. Yeah. When we talk about density, how are you talking about density?
G. Yeah, mass divided by volume.
Yeah, but so grams
Divided by milliliters.
divided by milliliters. So this cube right here is 10 centimeters. Can anyone relate centimeters to milliliters for me? George?
Centimeter is something that has a like a defined shape, and like milliliters is like with water.
Okay, but how do milliliters and centimeters relate?
They're both in the metric system.
Go ahead and jot that down. Micah, do you know the relationship?
1 milliliter equals 1 centimeter.
Ooh, careful. 1 centimeter.
Square.
Not squared.
Cubed.
Cubed. So guys, when you watch medical shows, if you ever do, when you hear people say, we need 100 cc's of that stat. Stat means right now, but cc's means cubic centimeters. Literally, they're saying milliliters, but cubic centimeters is the other way to say milliliters. So if we go to find the volume of this cube, it'd be length times width times height, or 10 times 10 times 10, which we, because we're mathematicians, we like to be efficient, could rewrite as 10 cubed.
So
When we find volume, if the shape is perfect, quote unquote, we are cubing, and this comes out to be 1,000. Either you can say cc for cubic centimeters, or you can say milliliters. So we now know there's 1,000 milliliters in that cube, and if we want to test that, there should be 500 milliliters left in my water bottle, because this is a 1.5 liter bottle, and my 500 mark is right there, and without being able to see it, because my vast amount of stickers, the water is there. We have dispersed 1,000 milliliters. Now, where I relate this lesson to more stuff that you guys don't have to know this year, but I want to teach you because it's fun, and I already got the water out. This pyramid, not a perfect 3D shape because it's not a cube. I can't cube things. So if we knew the edge length of this pyramid on the base was the same as the square, 10 centimeters, I want you guys to predict, if I shove this into this water, oh God, how much of this water will be displaced? So like if I shove it in and then I take it back out, how much of that water would remain, and or okay, if I try to go the not messy way, because my wife's coming in, I might get in trouble. If I dump it into here, how much of it will fit into here? So talk with your teammates. This is not like a problem from the lesson or anything. I just wanted to extend our lesson to talk about this.
Wait, how do you get a 40 without that?
Don't ask me, I'm making this up.
Wait, how does that
No, there's not. I wish there was. Yeah, I know. It'd be more fun that way, but. All right. Anyone have a prediction they want to share?
I'm still lost in blue.
Miss.
Because we know a triangle, like, if it has the same width and height, it's half of a square.
Okay.
So the pyramid would be half of the cube if they have the same length, width, and height.
Okay. I can see that being a reasonable estimate. So Micah's saying that because we know that a triangle is half of the area, can we extend that to say the pyramid would be half of the cube? Good hypothesis. Any other guesses? Now, Micah, how would that be different than if I had literally triangle to triangle instead of triangle up? Well, actually, here I have square up to a point. Where here I have triangle to triangle. So there's some similar. It's very similar. It's a little too small. So I wonder if that would hold true for this, because it's a triangle stretched to a triangle compared to a square stretched up to a square. But this is a square stretched up to a point. I worry that it may not fit half of it. So here would be my question: how confident are you? If I tell you, I'll try your hypothesis, I will pour half of this into here, but I will do it while I hold it above your head.
That's a wonderful idea.
How confident are you in that hypothesis?
Do it.
So let me ask you this. Hold on. Let me change my question. And as you can tell, like we've moved at a really good pace this year. So I want to, like, first off, thank you guys. But second off, I'm trying to make our lessons a bit more fun as we get towards the end of the year. Maybe kind of rogue from the textbook, but like I want you guys to think about these things and have this mathematical kind of like debate in your head. If I were going to make you this deal, that you will tell me what fraction of that volume to pour into this, but I do it while I hold it above your head. What fraction would you feel is safe?
3/4.
I'm asking you what fraction of the volume. So Micah said half. So I'm going to hold this above Micah's head and pour out half of that into here. You think half is safe?
Don't pour it into
Anyone disagree with the half? Anyone want to change it? So if I call you up here to do this, you're going to go with Micah's guess of a half. Quinn, you have a different one?
I say 3/4.
3/4? Quinn's getting bold. Any other? Simon? What? Simon says a third. Jessica? A third?
1/12.
A 12. Ooh, okay, so Connor's playing it safe. He's saying a 12.
I'm saying
Any volunteers?
Go
Quinn, come here. I gotta get it started back here.
Oh my.
I don't know that we're gonna make it to 3/4, Quinn.
Do it anyway.
Quinn said it. So I might lose my job if I soak Quinn. Are
are we gonna make it to 3/4?
No.
Now hold on. So there, I'm pretty much full.
That's
That's a fourth.
That's a third.
That's a fourth.
Oh, come on.
That's a 4.
Now this, hold on, this isn't totally filled.
It's a third. Not a 4.
Or when you were doing it on
Okay, okay, slow it a tiny bit. What?
That's a third. That's not a 4.
It's a fourth.
Fourth third.
So hold up. How much of this has been displaced? Now, watch this. We can prove this. Ah.
Paper towel time.
So, our pyramid. Okay, I know, I'm sorry. Not perfect and my table's crooked. Our pyramid takes up 1/3 of the volume. Now, wait, think about this.
I said 3/4. I wanted to.
Hold on, right on your paper, volume, investigation. Let's say volume investigation. That's bad handwriting. But volume investigation.
That's mine.
Volume investigation. So we said the volume of cube was 1,000 milliliters. And the volume of the corresponding pyramid, if we do the math, 333 milliliters. Now, think about this. Why are we dealing with cube as opposed to square? What determines that? Or how does volume compare to area? Sorry, think about this just a second. I'm going to orient my board again because this is annoying me. Why? How do you think we can make that like 1/3? I'm confused at how 3 comes into play here.
Because it was 1/3.
Yeah.
Simple logic.
But like, why is it?
Do you have to check my powers?
I do.
Oh, crap.
Oh, do this thing.
My favorite.
Or
Yeah, can you go to your fourth dimension?
So this is a really bad drawing. My sister stole the art skills. Don't judge me; it'll hurt my feelings.
Oh, don't worry.
So we just said that a pyramid's 1/3 of its corresponding cube, right? Same dimensions at the bottom. It's 1/3 of it. Now what if now finding the volume of a cylinder, that's not quite so easy, right? Because we can't just do length times width times height because the bottom doesn't have length and width. Do we think the same thing will hold true for the cone of the corresponding circular
Let's
side?
try, Frank.
Right, so same circle. Okay, we got some back table opinions. Marin? Why? Well, we're not doing that.
Oh,
I didn't even do it to Quinn. I just did you guys think I was going to? Using a third?
A third to a fourth.
Third to a fourth.
Careful.
So I'm doing it over this table. Yeah, it's okay. Guys, it's carpet floor.
Yeah, it's
What do you think, a third or a fourth?
a third.
It's a third. Still a third of it displaced, aside from everything that I'm
You mind if I
spilling.
go get some paper towels?
It'll dry. Yeah. Actually, here's the easy solution. Oh,
You know what that was?
so why might 3 come into play here?
Cube. Cube is 3.
Cube,
It's three-dimensional.
3-dimensional, coming up to just a single point. Ah, some really interesting stuff to think about. All right, we got to get back to our lesson because I went totally rogue. So now I bet you we still have time to finish this. Plenty of time. So if we had a cube that was 3 by 3 by 3. Hey Simon, is that you? Can you either stop that or leave? Because you're in 7th grade and I really shouldn't have to have this conversation. And I keep having to have it with a variety of people. If we are in 10-1 and we have an edge length, start getting real used to using edge length, and we use little e just because it's easier. Edge length of 3 feet of a cube, that means its resulting volume would be
What?
3 cubed, which is
27.
27. So the cube root of the volume tells you the edge length. So the cube root of 27 asks you what number, when we do that times itself equals the start number. This might actually need to be a semicolon, I think, in math when we write those things. So this is saying, here's what we're being asked when this has to be true. So that's why we kind of use a semicolon sometimes in math to like break what we're writing. Because this is not really a math symbol. It tells you these things are separated. So that result, we know, is 3. And we can work it forwards and backwards all day long. So if you look at 10-2, though, we're trying to find surface area of the cube. And I want to know if there's an easy way. Like some formula that when we're working with cubes, it'll always work. We can just do something real fast. So talk with your partners while I go dump out this water and try to deal with this mess. How do you think we can easily create a formula for any cube's surface area? We're going to abbreviate this S dot A dot. So you're going to go ahead and write that down. Take a couple minutes to talk with each other. I also have to go to look at my computer at 8th grade. Forgot about that. Now, sometimes I have a container under here to catch the water, but it's more fun when it spills everywhere. No, because these aren't necessarily What? It's just water. You guys say ew about weird things. Now, the funny thing is when I forget that table was wet and I'm going to sit. That, and it probably happened. Yes, I am, because I got so excited about our lesson. With edge. With edge E. So when we in math want to just say this thing is or whatever, we will often say with or given. We will a lot of times use the math word given. So another way we could write that is given a cube with edge length E. That would be another way to write that. Given a cube with edge length E. Forgot to stick my mark film and I gotta get my charger out. Yeah, if we didn't go over this, I have a heart condition. All I do is take a pill once a day for the rest of forever. Hopefully, that's all I do. Nope. It is in arrhythmia, which just means your heart gets confused and it like skips some beats here and there. But then it does. Really, it's called supraventricular tachycardia, but if we want to say procrastinator, it's probably easier.
Oh, that's awesome.
Yeah. Sorry, I just remembered that for the second time, and I needed to do it close to when I ate. So this, what do we call this when I pull all the sides out of a shape and I lay them out connected together? This is a net. Hey guys, in the back, bring it back to us. We've been kind of loose most of the class. But all right, so surface area, right? This is a net of your surface area of the cube. So what could somebody say about this net? It is comprised of... Braden? Okay, yes. Give me more. Micah?
6 faces.
6 faces. Give me more. Squares. Give me more.
Length and width.
Quinn?
I just realized something.
Yeah?
If you want to find the area or the surface area of a cube, all you need to do is square the side and then diamond it by 6.
Yeah, we did that like 5 years ago.
Yeah. Doesn't matter if you learned it 5 years ago. It matters if you remember it today.
Which I just
For a cube, what we all piece together, we have 6 identical squares. So this is where volume is actually easier, right? To find volume, we just take the edge length and multiply it by itself. For the surface area, and this is where people start to goof up because it's a different number that we use, it is 6 times the edge length squared. Be careful. Now, depending on the lengths, fractions, decimals, things like that, surface area could be bigger or volume could be bigger. Now, realize they're in 2 different units. So, whereas this will be something like centimeters squared, volume will be something centimeters cubed. I'm gonna start to get particular with this, guys. Those of you who have like been turning in papers with no labels and I keep writing label! Exclamation point, question mark. I'm gonna start to be writing that and getting it back to you with the progressive.
oh.
Okay, so hear me when I say put labels on your numbers, or as your 6th grade teacher maybe said because it makes you laugh, no naked numbers allowed. Connor.
If you use a shape that has made up of squares that are all the same size, can it be F times E square? Like faces?
Well, F would probably be the face, so we would probably call, if we were using F, it would probably be the area of the face. So you could say 6F if F is E squared, but we don't want to bring in a bunch of extra variables unless we need to.
Yeah, but
Right.
it's like not a cube, but it has all squares.
If it has all squares, then it's going to be a cube unless you make it some real weird,
Like a 3D octagon.
I mean, so we could talk later, but we're discussing cubes today because they deal with cube roots. Okay, so let us just stay here. So with that cube, what's our surface area? Well, it's 6 times,
Yes.
with that, and 9, right? 3 squared, or 6 times 9, which is 54 centimeters squared. Questions? So realize here our volume was 3 cubed, and it was only 27. So sometimes people will be confused and will say, wait, how's the volume less than the area? You cannot compare them. It's like comparing, I don't know, like an ice rink to a pool. Like one's flat, the other's not. It's 3-dimensional. It exists in space. This is flat squares. This is like 3-dimensional cubes. We can't really compare these numbers. So please don't say the surface area is bigger than the volume. We don't compare them. Okay? I'm trying to like nip some things in the bud right now because in past years I've had kids writing stuff and I'm just like, we need to think about what we're saying. You can't compare area and volume really. Cool? Does that make sense? Because they're different units. Okay. So in 10.4, we're going to skip 10.3. In 10.4, if these are the volumes of the cubes, find their respective edge lengths. So find if those are the volumes of a given cube. So they're all different cubes. What is the edge length of that cube? So essentially take the cube root.
How do you do it?
It's a good question, but I don't want to tell you yet.
No, we'll figure it out.
I will be right back. I gotta go deliver something to 8th grade.
By the time you leave, everyone thinks that I have a square root on the calculator.
If you want to find cube root on the calculator, go for it.
Wait, what do you press?
It's easy. Yeah, it's easy. Okay, so you press the second button.
Grab me a calculator.
And then you press we already do, right?
Oh, really?
Yeah.
And then it'll show you the answer.
So you're
Wait, how do you cube root something? How do you cube root something? Wait, how do you cube root something? Thank you.
very carefully. Now, just like square roots, some of these are like my wife, and they are perfect. And some of them are like me, and slightly unique. That's a nice way to say it.
Yeah, like
Yeah, that's what we are.
It's like when, a parent says, like, I love you because you're special. And you're like, yeah, I know what that means.
I know I'm gonna be special, right?
We have a fifth fourth trying to run away. Let's see if we're all awake. Quinn, cube root of 8, 2. 2, because 2 times 2 times 2 is 8. Cube root of 1. Now be careful when you write the work for this. We're no longer using the radical. Now we kind of are. The radical, though, when we've been using square root, does one of these math assumptions that I will apologize for. The square root technically has a little 2 right there, that if you don't write it, they assume it's a 2. So when we're doing cube root, we actually have to put the little 3 out here. We have to write it. So please write a few of these to get in that habit. What number times itself times itself? Jessica will make 125. 5, because 5 times 5 is 25. 2 times 5 again makes 125. Now, for those of you seeking the cube root button on your calculator, a few ways to do this. One way is knock stuff over. One way is the any root button. So if you're holding a calculator, navigate yourself to the caret button. Above it, don't type it. Above it, there's an X root. What that means is whatever you type before. Hey guys, not listening. I'm not repeating this. So good luck Googling if you don't listen. What you type before hitting this button will be your root. So that is called the any root button because you can literally do any root. Now beyond cube roots, things don't really make sense in the physical world. Like what does a fourth root mean? But we can still do it, right? The math doesn't have to actually exist for us to do it. It just helps us understand it if it does exist. The other option, and I would like you to try this if you're holding a calculator. When you type 125 and give it a power, like the caret button, cube roots are the inverse of powers. So instead of a power of 3, what's the inverse of that? Power of a third. In your calculator, once you hit the caret, now I would advise opening a parentheses and putting your power in parentheses, but try that. Do 125 to the power of 1/3. So depending on your calculator, guys, will depend on what buttons are available. Anytime we're trying to root, you can do it through powers, but then just flip it. Instead of a power of 3, it's a power of a third. Cube root 1/3. So square root, we could do 1/2 power, and that would get us square root. So if you take 25 to the 1/2, you'll get 5, because the square root of 25 is 5. So now moving on, cube root of 1,000. Yeah, I know. What is it? 10. Now we only did it because I did it, right? CPM didn't do it yet. And then cube root, we gotta write the cube for the 3 of 40. Yeah, if you do it in your calculator, 3.42. Now, if we try to go to reduced radical form, we're looking for, is there a perfect cube that can multiply as a factor of 40? So think through, let's think through a few perfect cubes. What's 1 cubed? 1, careful. 2 cubed? 8. Because 2 times 2 times 2. Yeah, guys, I would write these down because you're still not very comfortable with these. Watch how quickly these get big. What's 4 times 4 times 4?
64.
Look at this jump.
Oh my. And 260.
And you can write more out. But guys, if we try to reduce this into a simpler radical form, are any perfect cubes a factor of 40? Nope. So, cube roots, we normally don't try to reduce to another cube form. We normally just try to reduce radical form if we're doing square roots. Our radical is the symbol. You can use it for square roots and whatever, but there's technically a 2 there. We'll reduce squares. We don't really reduce cubes. You can sometimes, it just normally doesn't work very well. Questions? I think that's pretty much all we needed to cover. Let me double check that we're all good. Oh, by the way, they also start to say S is the side length of the cube. I oppose to them using that notation. Because side, give me your eyes for a second. Side, this is my side, right? This is the side of my desk. But this is also the side of my desk. On a 3-dimensional object, side could be the side facing east, which actually, that'd be this way. Side facing west, right? This side faces west. What side of the school? Edge has to be where 2 faces meet. So the word side is not specific enough. I seriously told CPM when we were at a meeting, I said, I don't like that you guys use the word side. And they're like, yeah, we realize edge would be more clear. But this is a side of the shape. But the problem is side can also mean a 2-dimensional object. Yeah. I would ask that we agree to use edge, right? And you guys will notice as you have Mr. Hall next year, he uses some CPM stuff, but uses a lot of his own stuff because he's been teaching math longer than I have. So he has a lot of great materials. I'm pretty sure he uses edge as well instead of using side. We can do these. So these are perfect cube roots. You know, we just thought through the list of perfect cubes. I should move this down. Here's a show us those as perfect cube roots. And this is where we can figure out using that Rachel method, kind of like what we did with square roots. What are we between? We're between two other perfect cubes. So we know we're between 3 and 4, but if we have a calculator, we can just use that. And yeah, spend your last 3 or 4 minutes either just shooting the breeze with your friends or start a couple homework problems.
We can't wait this one here.
Shooting breeze, right? You're shooting breeze. Yes. Ah, so. No, I love it. So Octavio wants to know more. Octavio said volume of a cone. Now, so we'll dig into these actually next chapter, Octavio. But the volume. Hey, if you're just talking, simmer down. So I'm trying to get Octavio to hear me. He's across the room. Hold on. I want to talk about this as a class. The volume of any straight shape. Give me your eyes for a second. So, this has nothing to do with sexuality before anyone goes there. A straight shape, in my mind, is one that starts with a shape on the bottom and stretches it straight up. Right? It's the same on the bottom and top. As opposed to, a cone is not. Right? It goes up into a point. So, any straight shape, no matter what is on the bottom, imagine you have a star that stretches up to another star. It's the area of the base, which we call big B, times the height of the object. So, stay with me. I have 2 minutes. Just.
Can you hold it a few minutes longer?
Yeah. Sweet, we're good. So, a cylinder. I don't understand why Big B is so funny, but okay. You want to let me in on the joke? No?
No.
Why is Big B so funny?
It's just a nickname.
Your nickname's Big B?
No, it's just B.
Okay.
Now I guess I'm
Big B. My nickname as a kid was Mitch because the Microsoft Sam, we thought it was so cool you could type in the computer and it would speak to you. Now that's like lame. Now you can talk to your phone. But when you would type my name Micah, it would read it Mitcha. So then my siblings started calling me Mitch. So hold up, real quick. In a cylinder, still Big B is the area of the base times the height, but in a cone, we still do the same thing, but because it's a cone, it's actually 1/3 the area of the base times the height. That's the same rule for the pyramid. 1/3 times Big B, whatever the base area is, times the height. Now, height here is a bit harder. You have to go from the bottom up to that point. So you have to seriously, off the table, how high is it? You can't just measure this edge because that'll be too long. That's actually going to be longer than the direct height from the table. So it gets a bit difficult. Do what? Yeah, exactly. You would stick a ruler inside of it. Or when we drop that line, that's called an altitude. Remember, any line dropped down to the ground is called an altitude. So work on your homework. We have to keep you a couple extra minutes.
I should have just
No, Octavio, you should always just ask the question. I appreciate that you asked it. Now, you'll need to know that next chapter. Well, actually, need, but I just wanted an intro. Yep, Pythagorean theorem, volume of a cube. There's a cone. Oh, yeah, well.